start. Let's do problem 10.1.21. I believe this is the finding a correlation between the price of a slice of pizza and the price of a subway fare. So they give us the data. They want us to construct a scatter plot, find the linear correlation coefficient R, and the p-value for R. Alpha is given as 1%, 0.01. So let's open the data in StatCrunch. I don't need the data anymore. So the two columns I want are subway fare and pizza cost. Notice pizza's on the Y, subway fare is on the X. So I go to Stat, Regression, Simple Linear. I select subway fare for X variable and pizza cost for Y variable. Everything else is set, so I just hit compute. Notice it says that, well, the hypothesis test is that rho equals 0, and the alternative is it's not equal to 0. We would use the bottom one for slope. Okay, so compute, and I want to, I'll put it, make it bigger. So it looks to me like D. I think D is the one. Obviously B and C it can't be. I think A and D are just upside down of each other, so it's got to be D. That's the correct one. All right. Now they want us to determine R. All right, so I go back on this left arrow, and here's the data, the summary. Remember, they use capital R here. The 3 decimal places, it's 0.990. So 0.990. Number lock. And that's what they want. And then they want, oh, there it is. There's the hypothesis. Remember, it's always that rho equals 0. That means there's no correlation. And if we can show there's that the p-value is less than 0.01, then there's going to be a significant correlation. In this case, it's a positive slope, so it's a positive correlation. The test statistic is right here on the bottom where it says slope. So that's 20.10, rounded to 2 decimal places. That's rather high. You'll see later on when we do more hypothesis testing that that's the case. And you can see the p-value to 3 decimal places is 0, so we'll just write 0. They'll accept it. So 0 is obviously less than 0.01. So the alpha, or the p is less than alpha. And the ditty says if the p is low, the null must go. So that means that we got to reject the null, and we support the fact that there is a significant positive correlation. So since the p-value is less than or equal to the significance level, that once again, that's p is less than or equal to alpha, there is sufficient evidence to reject the claim that there's no correlation. So they're saying the claim is in the null hypothesis, so we're rejecting that because we have, oh, what did I do here? Okay, so there is not sufficient evidence to support the claim that there is no, there we go, no. The p-value is less than or equal to the significance. Okay, so there is sufficient evidence to support the claim that there is. That's what I said the first time. Okay, I must have put one of those incorrect. So they're saying the claim now is in the alternative. We're supporting the claim that there is. Did they even make the claim? Let's see if they made the claim above. Support. Okay, I didn't read it. The claim is that there is a linear correlation. So the claim is in the alternative. So that's what we're supporting because we're rejecting the null. Okay, sorry for the confusion. Okay, based on these results, does it appear that the subway fare is always about the same as a slice of pizza? I have to look at the raw data to answer that. Let's see what the raw data says. I didn't really look at the raw data. Subway fare, pizza. Yeah, they're about the same. Look at that. They go up pretty much very similar. So yes, yes, because they appear to be correlated, heavily correlated. So if you just eyeball these two columns, subway fare and pizza cost, you can see that they're pretty much spot on, within a nickel or a dime of each other. A couple times a little bit more than that, but pretty much they're pretty close. That's why they're highly correlated. Okay, so that's it for question 10.121. This is Dr. K over and out.